St Mary's Catholic Primary School in Birmingham. And another day of lessons and learning. For Year 6, the day will include a science lesson on plants and growing. To find out what it's really like learning science at Key Stage 2, we're going to follow one pupil throughout the lesson to try and look at things through her eyes. Her name is Nicole and she is 10.
This afternoon we're going to continue our work on green plants.
So what does science mean to Nicole?
To do experiments and think scientifically. It's sort of like Mr. Blaney often says that we're young scientists.
It doesn't have like a proper flower head and the leaves are kind of yellowy.
What colour would you expect the leaves to be if it were healthy?
Kind of greeny.
The pupils have recently done some work on the life cycle of plants with Deputy Head Teacher and Science Coordinator John Blaney. But in this lesson, it's time for them to get their hands dirty with some experiments.
To start our science lesson today, I'd like to invite Anthony and Nicole up to the front.
Nicole and Anthony have been out in the school grounds taking photos of different types of plants.
They may have some questions for you.
Using ICT, their photos have been made into a presentation to begin the lesson.
What is this plant?
Is it a daffodil?
Yeah. It was fun, like, asking people questions, then asking them to answer you. You have to sort of think about what you're going to say before you say it, think of the question and think of the answer. And you have to think on the spot a lot, so it sort of makes you a bit more ready. What tree does this come from, Robbie?
A fir tree.
Yeah.
What vital role does this part of the tree play?
Cleaner.
Is that the seed? So
Well, it is sort of, Imogen.
does it play the role of helping the seed disperse?
Yeah, because inside of this, in the little sort of flappy bits there, the seeds are inside that.
So Nicole, thank you for that. You've covered most of the variables that we're going to look at in today's investigation, and it links very nicely to our learning objective, which is I will learn about the effects of light, air, water and warmth on plant growth. And in your groups today, you are going to investigate one of those variables in more detail, and in far more detail than we have previously, and come up with some firm conclusions on the factors that really affect plant growth.
Throughout their work, John Blaney has asked the young scientists to use post-it notes to plan which variables will be kept the same and which single variable will change. For Nicole's group, this will be light. Some of the groups will be working with seeds, assessing the amount of water and warmth they need to germinate. The other groups, including Nicole's, will be using seedlings as the basis for their experiment. They'll be investigating the amount of light a plant needs to grow.
If we're changing light, then what all we need to keep the same?
We need to keep the same. Yeah.
So warm, temperature, the amount of water, say, or water.
You'd have to keep the place where it was in the same, otherwise it might...
Yeah, it might alter the light.
yeah.
What shall we write for that?
Or just
Where it is, where it is.
Yeah, just place it.
Okay, next.
Won't you need to keep the same sort of soil, because you know that compost is heavy, and like soil like this, it's got lots of air holes in.
Yes.
Yeah,
And
so
very
the type of soil.
yeah.
Okay.
If we were to replant it.
Yeah. We are replanting.
Okay. We probably need to keep the how dark it is. Like, no, to keep it. If we're taking away light completely, then we need to make sure that it's in total darkness.
Okay. So that would make the test fair then. So if we took away light, we will keep the same warm amount of water, where it is, type of soil and darkness, okay? Yeah.
Nicole's group have decided on the factors affecting a seedling's growth, and she's off to put their note on Mr. Blaney's chart. Nicole hesitates, and with good reason. She wants to be certain the note is placed in the correct column, either under seedling growth or germination.
I was just thinking about whether it was seedling growth or germination, but it's seedling growth.
Mr. Blaney has come to check that Nicole's group have designed a fair test for their experiment.
Now you've got 3 pots. You can replant 3 of these, choose the ones that you think would make it fair, use the growing mix here to do that. Now you need to control the light in your investigation.
The agenda today is science. But by looking closely at how Nicole participates in the lesson, we see her using the fundamental skills of listening, speaking, asking and answering questions, and writing up work. She's drawing on a complex range of crucial communication skills.
Is that going to affect the amount of light that reaches the plant?
Yeah.
It is? Does everyone agree with that?
No, not if you tape it down enough.
Can you look through that? What can you see? How are you going to change the amount of light reaching the plants?
Nicole checks with her team before writing up the details of their control to go on the chart.
Are we going to repeat anything?
Well, which round we choose? Like, we'll have a bit more light. No.
Yeah.
No, we're not allowed to use that one.
No, get that one. No, get that one.
No, maybe that one, yeah.
That one in the corner.
So does she have a good grasp of the experiment her group is going to do?
Our experiments are replanting these seeds and then we're controlling the amount of light in them, and the experiment is to see how light affects growth of the seedlings. Okay, so we borrow the spoon, please.
Why do we need seeds? We don't. We're replanting them, so we don't need seeds. We get our plant these.
Right, so what's next? We need to push all this down. And then we need to put this in. Be careful. Yeah, right.
The mechanics of planting out the seedlings from their containers are proving a bit of a challenge.
Go on, if you hold it, then I can hold this again.
Yeah, that'll try.
No, it won't go that way. It's fine as it is.
The girls are anxious not to harm the delicate seedling and don't want to break open the polystyrene pots.
That one's just growing, can you see that? If we were to just pull it up, then the leaves would probably break, so we have to sort of try and gently dig it out.
Close cooperation is being called for, and Nicole and her friend are tenaciously applying themselves to the task in hand. They're determined to solve the problem for themselves.
Shall I try it? 2 seconds. Can I try it? Yeah, sure. There are actually 3 seconds.
The pair's patience pays off as Nicole offers a solution.
I reckon that if we were to push from underneath.
Oh yes.
Okay, shall I? That's it. Just tip it upside down. The roots are right at the very bottom, so trying to gently ease it out. It's coming out. Keep doing it. You need to catch it.
Dexterity is a useful skill when solving problems in science, which makes this a valuable learning experience.
Yes. All right, here we go. Right, now there's one.
Yes.
So we need to plant that one in.
Okay, then how are we going to put the roots in there?
If we just plant it, then it should re-root itself a little bit. You need to make small holes, don't you? You make a sort of dip and put yours in.
So, what happens next?
Well, we're going to have to water them so that they're nice and moist, and hopefully then they'll keep on growing.
I think you're doing well though. Keep going.
We're thinking about putting tin foil over the top with the different experiments, putting holes into the tin foil, or using one in total darkness by having the canister on it, then another one in slight darkness by having tin foil sort of like, and we'll pierce some holes to see so that it lets in some light, and then on the other one more light again. We thought foil would be good because you can put holes in it easily.
More painstaking surgery is occurring on the other tables too.
Make an even bigger hole, it needs to be gigantic.
There's another one there.
We have to have for you.
Based on what she's learnt so far, what is Nicole's understanding of what plants need to grow?
Plants often, because they're under stress, then they keep growing to try and find the light.
And then the leaves turn yellow.
Yeah, but then it might be the one that has the most light because it has enough light to grow.
How's it going over here?
I think it's really important that the teacher should go around all of the tables and sort of chat with the table and sort of make sure that they fully understand and on the right tracks, and if not then sort of prompt them but not tell them the whole thing, because you need to be able to think.
On one of the other tables, a soil and fertiliser recipe has been concocted to germinate seeds.
We're trying to see how the plants will react in different temperatures. Some in hot temperatures, we're putting some in cold temperatures, and we're putting some in warm temperatures.
I think Mr. Brown meant to put it so that it went round.
Do you mean like stick it?
Completely down. Like this.
Okay, well, what's yours? Is yours total darkness or?
No, there's a slot.
Right, we'll just put one slot in ours then.
What do our Year 6 scientists predict will happen in their seedling experiment?
This is the one with the most light. This is the one in complete darkness, and this is the one with sunlight.
No, I think that this one will grow quite tall.
Yeah.
We may have to actually change this and make it bigger but still keep it in complete darkness. This one will grow quite well because it'll be quite healthy because it has enough light and it's got everything else. And then we don't think that this one will grow too well because it's only got quite a small bit of light, but it may grow quite quickly upwards because it's searching for the light.
It's the end of the lesson. Now that the class have soiled their hands in the name of science, it's time to load up the light box and to reflect on what they've learnt.
Just to go back to our will, what I'm looking for to make a successful lesson which meets our learning objective, I will learn about the effects of light, air, water and warmth on plant growth. Have you found ways to change one of your variables? Do you think so? Just raise your hands if you think you've done that today. Well done, I think so too. I've looked and read through the table and lots of good ideas here how to change your variables. I was pleased that those of you who are changing the amount of warmth thought about using the fridge and thought about using dictionaries to raise your seedlings or nearer the light source, which was very good. And I'm pleased that you've come up with lots of ingenious ways to vary the amounts of light, including using the canisters and tubes provided and putting holes in them. So that's very good indeed. Well done. And
the science lesson has been a success, and for Nicole, perhaps even more beneficial than she realises.
Growth. Have you agreed between you who's going to water it, who's going to measure the growth?
So, what does she think?
It was fun. We did quite a lot of practical stuff, and when you're doing an experiment, thinking about what you'll change, what you'll keep the same, and thinking ahead and predicting sometimes. It went quite quickly because it was fun.